Hi students, Professor Nugent here. Let's begin a discussion of weak instruments in a two-stage IV setup. Define the first stage as y2 equals pi naught plus pi 1 times z1 plus pi 2 times z2 plus u2. The second stage as y1 equals beta naught plus beta 1 times y2 plus u1, where we plug the estimate from the first stage into the second stage. We have assumed that pi 1 and pi 2 are not equal to 0, so that the instruments z1 and z2 are relevant for y2. Now we ask, what are the consequences if the instruments are only weakly relevant? If the instruments are not purely exogenous, so if z1, z2, not purely exogenous, and that is the covariance between covariance between y2 hat and u1 not equal to 0, which will be the case most of the time to some degree, then the strength of the instruments is important. We're first going to talk about the strength of the instruments in terms of inconsistency. We'll then look at the partial R squared, and in the third video on weak instruments, we'll look at finite sample bias. So let's first think about inconsistency. It is straightforward to model inconsistency in the limit. The probability limit of beta hat OLS is equal to beta plus sigma y2 u1 over sigma y2 squared. The probability limit of beta hat IV is equal to beta plus sigma y2 hat u1 over sigma y2 hat squared, where y2 hat comes from the first stage. Now, if the instruments are purely exogenous, then the numerator will be 0. The covariance between y2 hat and u1 will be 0. However, if the instruments are not purely exogenous, then there will be some inconsistency. So again, consistent estimates, they're obtained for either estimation method when either numerator in OLS or IV is 0. Okay, if any of these cases fail, then we have inconsistent estimates. And we can model the relative inconsistency of IV to OLS as follows. The probability limit of beta hat IV minus beta all over probability limit beta hat OLS minus beta. This is equal to sigma hat. Well, we don't need sigma hat. This is sigma y2 hat u1 over sigma y2 u1 all over sigma y2 hat squared over sigma y2 squared. Now this is equal to sigma y2 hat u1 divided by sigma y2 u1. So these are the covariances. And the denominator we can rewrite as r squared y2 z. So it's the coefficient of determination from the regression of y2 on z. Observe that the relative inconsistency of IV to OLS will be smaller the larger is the coefficient of determination from the regression of y2 on z. Hence, the better are the instruments z, the larger will be the coefficient of determination, and the lower will be the relative inconsistency. Stay tuned to the next video, and we will discuss using the partial r squared to help us think about weak instruments or potentially too strong of instruments.